Welcome to another Earth Science podcast. I'm your host, Mr. Buss, and this is going to be the last podcast for Unit 1. We're going to go over the final overview of the inside of the Earth, and I'll try to make this one short and sweet. So here we go, starting with the inside, going out. So we got the core and the inner core first. The inner core is solid. How do we know it's solid? Well, I'm not going to get into the details, but it's because of earthquake data. Specifically, I guess I will get into the details. A type of wave called S wave stops at the inner core, so the inner core of the Earth has got to be solid. We know it's iron and nickel, not because we've gone there and checked it out, but because we can actually calculate the density of the Earth, believe it or not, and the density of the Earth is heavier than it should be if all the rock on the Earth were made of rock that is similar to rock on the crust. So it's got to be heavier stuff, and we see a lot of iron and nickel in meteorites, and so we've inferred that the core of the Earth is probably a lot of iron and nickel as well. All right, the outer core next. Outer core of the Earth is also iron and nickel, but it is liquid. And it is this liquid outer core and the convection currents of the movement of the liquid in there that is actually responsible for Earth's magnetic field. So to repeat, the liquid outer core of the Earth responsible for Earth's magnetic field due to convection currents, movement of the liquid metal. And that's why Earth's magnetic field will change from North Pole to South Pole. It'll rotate and wander because the liquid also wanders and the convection current wanders as it moves around in the outer core. When you combine the solid inner core and the liquid outer core of the Earth, you're going to get a total mass of 31% of the Earth is the core of the Earth between the inner and outer core. All right, let's talk about the mantle next. All right, so the mantle is classified as hot rock. Basically, you're going to think of it as liquid because there is convection in the mantle. And remember, it's this convection, this movement of this magma and hot rock in the mantle that is responsible for plate tectonics and seafloor spreading. But it's basically, think about it as soft rock and just very gooey hot rock instead of just a really liquidy type of rock. And if we're talking percents, the mantle composes 68% of the Earth by mass. So, not much left. If you combine the totals of what I said, the core being 31% and the mantle being 68% of the Earth, wait a minute, we're up to 99% of the Earth has already been spoken for, which leaves a measly 1% of the Earth left to talk about when we talk about the crust of the Earth, or that part of the Earth which we experience. So the crust is described as a cold, thin, brittle outer shell made of rock. It's very thin relative to the radius of the planet. And there's two important types of crust which we need to talk about right now. And they are oceanic crust and continental crust. Okay, so oceanic crust is basically formed from magma that erupts on the sea floor to create basalt lava flows. And it's going to be an intrusive igneous rock, whereas continental crust is made up of many different types of rocks, igneous, metamorphic, sedimentary rocks. And on average, continental crust is much less dense than oceanic crust, meaning it's not as heavy. And so anytime oceanic crust and continental crust collide, the denser, heavier oceanic crust will go underneath continental crust. And we talked about that in our previous podcasts. All right, I'll let this be my last slide of the podcast series here for this unit. I think this is just a tremendous slide because what it really shows is it shows so many of the different aspects and concepts that we've been talking about all kind of on one. This isn't really an exact place on the Earth. It just shows all the different things that we could talk about here. Subduction of ocean crust under ocean crust, creating island arcs such as Japan. You have a hotspot where you are forming island chains, which is much like the island chain of Hawaii. Here you have a mid-ocean ridge and you have rift going on. We talked about all that great stuff. We talked about the deep sea trenches here, where you have ocean crust subducting under continental crust, and you get the Andes of South America, for example. A lot of volcanoes there as well. We talked about the African Rift Valley, and you have new rift forming here, just like you do in Iceland. So many things going on in this picture. And again, what drives it all? The convection, which isn't shown on here. The convection, the movement of magma up and then getting pulled across the crust and then back down. So these convection cells, which aren't really shown here, are the driving force, the mechanism behind plate tectonics. And that concludes this podcast, the final podcast for Unit 1 Node Outline, the final overview of the inside of the Earth. Thanks for joining me.